Hi, everyone. Welcome to Affectiva Asks, a human-centric AI podcast, where each episode we will interview a thought leader doing cutting-edge work in the AI space. A little bit about us. Affectiva is a pioneer of human perception AI, software that can detect nuanced human emotions, complex cognitive states, behaviors, activities, and interactions. And Affectiva is applying this technology to advance the next generation of multimodal in-cabin sensing. Today's episode features our CEO, Dr. Rana el Kaliouby, interviewing Lisa Feldman Barrett, Distinguished Professor of Psychology at Northeastern University, where she focuses on the study of emotion and she directs the Interdisciplinary Affective Science Lab. During their interview, they discussed Dr. Barrett's background, her recent research paper on challenges inferring emotion from human facial movement, and how Affectiva is a leader in mapping contextual variability with multiple signals in our technology for detecting human emotions.
Hi, everyone. It is my pleasure to interview Lisa Feldman Barrett, Distinguished Professor of Psychology at Northeastern University, where she focuses on the study of emotion and she directs the Interdisciplinary Affective Science Lab. Welcome, Lisa. We're so excited to have you with us today.
Thank you so much for having me on your podcast.
So tell us about your work and how you got into the field of emotion research.
Oh, well, I tripped into the field, actually, when I was a graduate student. So I was studying the self and trying to understand self-esteem, and I was using some emotion measures that weren't working particularly well. And so I thought, I can solve this problem really easily. I know that I took intro psych. I know that there are 6 basic emotions that each have their own facial expression, each have their own bodily comportment, their own bodily pattern. So if I just want to know how people are feeling, I can just assess objectively by measuring their face or measuring their body. Everyone knows Darwin said there were, every emotion category had its own facial expression. And so I went to the literature with tremendous hubris and thought, well, I'll just learn how to do facial EMG and I'll measure people's faces and I'll be able to read their emotions. And lo and behold, I discovered actually you can't put more than 3 or 4 electrodes on people's faces, which means you can measure 3 or 4 facial muscle movements out of depending on how you count, dozens or more. And in fact, the evidence didn't really seem to me to be indicating anything even close to the idea that there are universal expressions. And the studies that showed universality had methodological glitches in them, I thought. And so I just moved on. And actually, I went back and read Darwin and read what Darwin had to say about facial expressions and discovered actually everyone is misciting Darwin and what he said in, on.
Can you say more about that?
Oh, yeah, sure. I mean, people cite Darwin and they say, well, Darwin writes that facial expressions evolved through natural selection because they're adaptive and they're communicative in their adaptive, in their function. And Darwin actually says nothing of the sort. Darwin says facial expressions are useless, that they were once useful in some ancestral animal, but that they're now like vestiges, like a tailbone, which suited him really well because he was trying to show that non-human animals and humans have common ancestors. And so if we have some morphological features like tailbones that are no longer useful, but they're present. That's an indication that it's like evidence that we evolved from a common ancestor. And so Darwin thought that there were certain behaviors that humans showed that were similarly vestigial, and that's how he understood facial expressions. He also thought facial expressions evolved via Lamarckian evolution, not by natural selection. And so the idea that we have these functional facial expressions that are universal in their functions and that they evolved through natural selection really comes from a later reinterpretation of Darwin. Actually, the major reinterpretation was Floyd Allport in the 1920s, who was the brother of the very famous Gordon Allport, who was a social psychologist at Harvard. And even further, I would say Darwin when he wrote about facial expressions and emotions more generally, used a really essentialistic view, deeply essentialistic view of emotion that violated his own insights On the Origin of Species. So Darwin in biology is famous for vanquishing essentialism when it comes to biological categories like a species, where, there is no prototypical example of any species. Any prototype is like an abstract summary of highly variable population of instances within the category. So there's no perfect Cocker Spaniel, right? There's just the iconic Cocker Spaniel, which is a fiction. And really what you have are lots and lots and lots of Cocker Spaniels, right, which are highly variable in their features. So he wrote this really important book about variability, and then basically contradicted it a little more than a decade later when he wrote On the Origin, and when he wrote, The Expression of the Emotions in Man and Animals. And so I think that's really interesting. I talk about this in my book and about what it might mean, but I can tell you simply what it means is that a lot of people are not reading Darwin when they cite him.
And so then how did you end up focusing on affective science?
Well, so I just kept going. So I said, okay, well, it's not the face, it must be the body. Everyone knows William James said, famously that every emotion has its own physical signature. And it turns out, no, he didn't say that. Actually, he said the opposite of that. He said every instance of anger that feels different will have its own physical signature. So when he speaks of emotion, he's speaking of instances of emotion, not categories of emotion. And in fact, the data show this variability that William James famously wrote about. And so I just kept going, and I actually learned to be a neuroscientist. I learned neuroscience because everyone I knew who knew something about emotion was saying, oh, well, if it's not in the face and it's not in the body, then it must be in the brain. And I was like, okay, well, then I guess I'm going to have to learn, So basically I started off in clinical psychology, and then I learned social psychology, and then I learned psychophysiology, and then I learned neuroscience, in part trying to chase the answer to the question of what is the physical basis of emotion categories. And so here we are 25 years later.
So recently you published a research paper entitled Emotional Expressions Reconsidered: Challenges to Inferring Emotion from Human Facial Movement. In this paper, you state that there are challenges in the approaches taken to inferring emotion from facial expression. Can you kind of summarize your main findings in this paper?
The main findings are that people move their faces in a variety of ways in the instances of any given emotion category. So people don't only scowl when they're angry. People don't only scowl when they're angry. They cry when they're angry. They smile when they're angry. They pout when they're angry. They can have a completely still face when they're angry. People do many things with their faces when they're angry. So it's not that they're doing random things with their faces, right? It's that they're tailoring their facial movements to communicate anger in a highly specific way that is specifically situated to the context. So the stereotype really is that people scowl in anger. That's the Western stereotype. And
Right.
People do scowl more than you would expect by chance. For sure. That's what the data show. About, somewhere between 20 and 30% of the time. So that means 70% of the time, 70 to 80% of the time, people are doing something else with their face, right? So that means if you equate scowling with anger, you're wrong 70 to 80% of the time. And the reason why I say this is that people also scowl when they're not angry, pretty frequently, actually. People scowl when they're confused. They scowl when they're concentrating. They scowl when they're curious, or really anytime they're focusing their attention. People sometimes scowl when they burp or when they have discomfort in their stomachs. People scowl for lots of reasons, and many times it's not emotional at all. So the first thing to understand is that there's a tremendous amount of variability, and what people believe, when people believe there are universal, prototypes, that's really a stereotype, and it's actually a really Western stereotype, to be frank. And we also discovered that when human perceivers, so you and I are right now looking at each other,
Mm-hmm.
and we're making judgments about each other's faces, right? We're making judgments about what each other might be thinking or feeling based on our facial movements. When we do this in real life, humans are really good pattern learners. So you and I know each other a little bit, right? This is not the first time we've met,
Right.
but we're not best friends yet. We haven't spent tons of time together. But as we spend more time together, we will learn more about what each other's facial movements mean. And we do this really well. And what this means is that, Rana, you probably have a whole vocabulary of facial movements that you make when you're angry, and a different vocabulary that you make when you're sad, a different vocabulary that you make when you're interested. And some of those might overlap, right? So sometimes exactly the same facial movement might mean interest, and or might mean I think you're full of crap, depending on the context. And I will learn that over time through our interactions. And so what this means is that studies, the majority of studies actually on emotion perception, which is where claims of universality came from, are really based on a very simple method that for decades has been known to provide inflated estimates of universality, where you show someone a posed, exaggerated face. So a pose of a scowl that's highly exaggerated, it's static. So there's no temporal dynamics. It's just a static photograph. And you give people a set of words, and you ask them to pick the word that matches the face. Or you might tell someone a little story that's impoverished and has no context information, like Bobby's dog died, Bobby's sad. How does Bobby look? How does Bobby express his sadness? And then you show a pout and a smile, and then the person has to pick. When you do these kinds of experiments, which are called forced choice experiments, you see really good evidence, strong evidence, I should say, that emotional expressions are recognized across cultures in a universal way. But here's the thing. If you take that method and you take emotion categories that don't exist in English, that have never been claimed to be universal, and you just make up facial expressions and you make up vocalizations, and you plot the vocalizations, let's say, with the emotion categories that don't exist in English and that never have been claimed to be universal and that don't exist in the cultures that other cultures you're testing, 5 of the 6 of them come out looking universal in that method. So there's something interesting about the method. It's not, other people who've researched this talk about the method being flawed. I don't think the method's flawed. I think the method is showing evidence of something that's important. It's just not universality. What this method is showing is that you can give someone a word for an emotion that they've never heard of before, and you can give them facial movements or vocalizations they've never encountered before, and you compare them after just 1 or 2 times, and people learn them really fast. That tells you something about the power of words in learning categories, especially emotion categories. But it doesn't say anything about the universality of those facial movements as emotional expressions. And so we verified this in not just the studies from my lab. My lab's been to Namibia, and we've been to Tanzania, and we've done these experiments with people from remote cultures. But now there's just there's a wealth of evidence from those cultures, from a range of remote cultures, showing that these expressions are not universal. They're not universally recognized in any way.
This really resonates with me because I did my PhD between 2000 and 2005, and I was, really kind of I flagged this concern that there is so much obsession around the 6 basic emotions and this naive, I call it one-to-one mapping between a facial expression and a stereotypic or a prototypic emotion, right? And I really try to focus my PhD research on demonstrating that, in fact, you can scowl, for a number of reasons, and you may be angry. Sometimes scowl when you're angry, but often you may not, right? And so there's this M to M complex mapping, and I wanted to try to build an algorithm that can encapsulate this complexity, and this has continued to form the underlying methodology of our research at Affectiva. And it's kind of interesting that, I published my research in 2005, and 14 years later, there's still this continued obsession around the 6 basic emotions, and it's not a solved problem, both in academia and industry.
Well, I would say a couple of things. One is that there's an obsession with these. There's an obsession, really, a deeply, deeply held belief about the priority of these categories, which are not basic. They're not basic by any definition. They're not biologically basic. They're not psychologically basic. Some of these categories don't even exist in other cultures. And so there's at least one culture on the face of this earth that doesn't have, one of those categories. So, I mean, there's tremendous variability, and there are many categories that we have very powerful brains that can do conceptual combinations. So we can understand categories because we can make them on the fly, even if they don't exist in our culture, even without words, right? It's just they have to, in order for them to persist, we need words or some kind of symbol for them. But there's a real, dedication that people show that I think sometimes goes beyond. Not sometimes. I'm trying to say this delicately. That
you don't have
that
to.
when people won't give up a hypothesis in the face of overwhelming evidence that it is not true, that's not science anymore. That's an ideology. And people hold ideologies for lots of reasons, I would say. But the other thing that I would say is that, the people who are critical of our paper and who've been critical of my lab's work point out that they know that there's variability, right? But when they talk about there being variability, they're talking about a little bit of variability around a prototype. A prototype implies that facial expression, that facial movement, is the most frequent and also the most typical. And neither of those things are true as far as we can tell. So there's tremendous variability that far outstrips any basic emotion perspective, any theoretical perspective that refers to those or hypothesizes that those particular facial configurations are prototypes. They are not prototypes by the standard psychological definition of a prototype. They're just icons or stereotypes or symbols. And people are very fixated on them. Not everybody, but it's I think that that if the goal is to detect emotions in nonverbal ways, then scientists and industry have to go about it in a really different, go about that process in a really different way, which is something that we discuss in our paper. And I should also point out that our paper was authored by 5 scientists who came to the project, not agreeing theoretically. So we did have a couple of people who really took a basic emotion perspective. And we had a couple of people who took appraisal perspectives. And what we all agreed on was that we were going to try to stay very true to the data, despite our priors, despite our theoretical preferences. And I think we did that. It took us 2 years, but I think we did that.
So let me ask you this. So since the paper has been published, quite a few folks have approached us as they have concluded from your paper that Affectiva's technology is scientifically invalid. What would you say to that?
Well, what I would say is, what is your claim? Right. So in science, you can't say that a method is valid or invalid. You say a method is valid for a purpose or it's invalid for a purpose. So what's the claim what's your claim? What is Affectiva's claim of what it's doing?
So our approach to kind of solving this problem, and I wouldn't pretend that it's all done, is to first identify what is happening, to be able to automatically, using technology, quantify what is happening on the face. So I kind of call it like the building blocks or the facial action units of what's happening on the face, right? And this, in my opinion, is objective. It's devoid of meaning. You're just describing what these action units or facial movements are. So that's level 1. Level 2, which is more complex and it's very context dependent, then we map these building blocks or combinations of these facial action units into a number of states. Not just emotional states, but to your point, sometimes they're social states, sometimes they're cognitive states like fatigue or drowsiness or cognitive overload. And our approach to doing that is to take into consideration as much contextual information. So we want to know if you're driving versus watching a Netflix, video, or maybe you're playing a video game. We also use real world data. So all of the data we've collected is spontaneous, natural data in the wild. And then we've started taking a multimodal approach. So we also combine things like vocal intonation in addition to your facial movements to infer this meaning. So that's our general approach. And the states that we're interested in are very dependent on the context. So in automotive, we're very focused on things like, expressions of joy, but primarily driver impairment states like drowsiness, levels of drowsiness or attention or distraction. So that's kind of what we're trying to do. There is a lot of pressure from the industry to provide the 6 basic or the 7 basic emotions. And we try to, we think of ourselves as thought leaders, and we try to educate our partners on when this is relevant and when sometimes it's not.
Right. So I guess what I would say is any company which claims that it can detect sadness, anger, fear, that it can detect, so that it can detect anger by detecting a scowl, or detect sadness by detecting a frown or pout, detect happiness or joy by detecting a smile. Any company which equates, a single facial set of facial movements with a single category, or even a variety of scowls with anger, right? As any company which is doing that is misunderstanding what the evidence says. I think researchers in academia now have studied up to 20 categories. There have been claims that over 20 actually. There have been claims that there are these prototypes for in the voice and in the face for over 20 categories, and the problems with that we find in the literature on the 6 categories that we reviewed in the paper, which are the most frequently studied. We see this in really the evidence for the published evidence for every category. I mean, like, it's just, it's not special to those 6. It's the problems are, and the findings are what they are across really all the categories have been studied. So I would say if, Affectiva is taking a multimodal approach, that's really important. I would suggest, as we do in the paper, that the problem is more high dimensional than just body postures and vocalizations, that we have to also be considering other types of contextual data, including what's going on inside the person's body and also what's going on in the social environment. So it's not just the situation that they're in or the task that they're doing, like are they driving versus playing a game, but also who else is there.
Definitely.
How well do they know that person?
Right.
I mean, we're social animals. Our nervous systems coordinate. If you and I are getting along and we like each other and we trust each other, then our heart rate synchronize, our breathing synchronize. What's going on in your body is a context for my facial movements and vice versa, right? So we have to be measuring the context in a much, much more high-dimensional way. I think we also have to be using conditional probabilities in terms of temporal So the context isn't only spatial, it's also temporal, which I know is something that, that you're really interested in. And I think, considering variability across contexts is exactly the direction that you should be going. I would suggest that I would nudge you further in that direction of mapping variability and say, there may be individual patterns that people show that might be somewhat specific to them, right? Or that maybe probabilistically you see. So you're talking really about distributions of expressive forms, right, within a given situation.
Right.
So what I do when I'm driving might be what you do, but you grew up in a different culture.
Right.
So we may have some overlap in our distributions, in our vocabularies, right? But maybe not complete overlap. Or, if you were a man, maybe, and I'm a woman, or I could be the man, you could be the woman. But, if we're,
Right.
or you're non-binary, I don't know. But, but the point is that that there may be, we might be able to even map the similarity in our vocabularies of facial movements when we're driving, for frustration or what have you, depending on like particular dimensions on which we're similar or in which we're different. That's also a possibility. So I think my point is that I think that Affectiva is going in the right direction by targeting multimodal measurement, by trying to map variability. But I think the variability is even greater,
Right.
potentially, than you're currently doing. That being said, I mean, I'm not aware of what every company is doing, but I can look at the internet. I can see what people are claiming. And it seems to me like what Affectiva is doing is going in the right direction. And I can't say that about every company that advertises. If I go by what they say, of course, they could be doing things that they're not talking about, right? But if I go by what they say, then I think Affectiva is a leader in trying to map variability, and particularly contextual variability, and trying to use more than one signal. I don't there aren't a lot of companies that are shouting from the rooftops that that's what they're doing. Instead, what they're claiming is that reading a scowl is reading anger, and that's really problematic. I guess just to repeat myself, what I would say, just for emphasis, is I would just push you further in that direction, because I think that's the right direction to go.
Yeah, one of the ideas we both have kind of talked about is this potential collaboration, because as you know, we have collected over 8.3 million face videos from 87 countries around the world. It's very, it's all spontaneous responses to a variety of content and contexts. And in my opinion, we've only started to scratch the surface of what this data is telling us. And I think there's a real opportunity to collaborate with leading labs like yours, where you could, build a number of hypotheses and test them on what this data is really telling us. I feel like we've got all this data. It's very global, very ethnically diverse, gender diverse, age diverse. But I don't believe we've really mapped it out.
Mm-hmm.
In terms of what it's telling us. I think there's a lot of opportunities to do multimodal research, to do temporal research, right? Like what's the temporal distribution of these different facial and vocal expressions? So I guess my question to you is, how do you see industry and academia potentially collaborating to change this very deeply rooted perception?
Yeah, so let me say a couple of things about this. One is that I think the only way this problem is going to be solved is by, scientists in academia and scientists in industry collaborating. I think the problem that we have before us is a solvable problem, but it is a problem that requires asking different questions and being willing, having the tenacity and the patience and the being willing to fund the research that's required to answer the question. So people are phrasing the question in a very simple way, because it's easy to answer that question. Unfortunately, it's the wrong question to be asking, and it's not going to get people what they want. When I say to people, people say to me, oh, aren't you being too picky, right? And I say, well, okay, if let's imagine that you're in a court of law and you scowl when you're concentrating. You're a defendant. Somebody's accused you of something. You're scowling because you're actually concentrating really hard. And the jury is given evidence from technology that you're scowling, so you're angry. And, it's going to be wrong 70% of the time. Would you want your outcomes legally to be determined by an algorithm that is going to be wrong, not in its detection of physical movements, but in its inference about the meaning of those movements? Would you want your, and of course they go, no. So I guess my point is that I think in the last 10 years, give or take, it could be longer than that, I don't know, but, what the technology, what industry has done is pushed forward technological developments that now allow us really for the first time to be able to measure many data streams, many signals simultaneously in a higher dimensional way, and model them in a more sophisticated with more sophistication in their temporal dynamics. And we can get big data on individual people across contexts. And when I say this, sometimes scientists in academia will say, well, that seems like a lot of work. Like that seems really hard. That seems really expensive. And the truth is, it is a lot of work, and it is really hard, and it is really expensive. All those things being said, it's doable. But the scope is different. Scope is different from the magnitude of variability that we're talking about is much different than I think what people initially thought. And so in order to solve this problem, you need to recalibrate your expectations, and you need to recalibrate your how long you think it's going to take and what you're willing to spend. But I think it's doable. If we invested, we as in globally, we invested billions of dollars, to build a hadron collider so that we could discover a Higgs boson, then I think if we invested the same amount of money in trying to solve these problems that are important for human outcomes, I think we could. But we have to realize that that's what needs to be done. And the truth is, the government, federal funding, is not going to pay for it. Is not going to pay for it. And frankly, we all know, any of us who've sat on review panels, study sections, peer review is really important. I'm not knocking peer review, but for really innovative problems, peer review is important, and it's necessary, and it's conservative. If you want to solve a big problem and you want to solve it quickly, you need a magnitude of money and a willingness to take risks, right? High risk, high reward. That is not generally the case. It's not generally what you find in federal funding streams. There are some, I had a Pioneer Award from NIH. Mm-hmm. It was a fantastic award. It's a for high risk, high reward research, but just by comparison of scale, that was like a $500,000 a year in direct costs. When we in my lab and with our collaborators computed the estimate to do the kind of study that we thought was necessary with some of the technological development that we thought was necessary on like a very global, but on a small number of subjects, just deeply observing them, right? Mm-hmm. It was more on the order of $15 to $20 million. Right. And that's just for a pilot study. Now, that sounds like a huge amount of money to people who get federal funding. But when you consider, industry investment. Exactly. So, what I always say to people is, listen, if physicists were funded at the level of behavioral scientists, they never would have discovered the Higgs boson. Can we solve this problem? For sure, we can solve this problem. Can we figure out how to, have a really good probabilistic inference about someone's state? I honestly think that's possible, but it's going to require acknowledging the fact that there isn't a one-to-one mapping. It's many-to-many, and the state in its measuring the state will require extremely high dimensionality in the data, and dealing with things, with temporal dynamics, and always probabilistically. And that's going to be hard and expensive and like a lot of fun, probably.
Yeah. But the good news is the availability of the data. You could see how with the ubiquity of all sorts of sensors, this data could be made available. And it's often available to industry, right? Like in our case, for example, we do have access to all of this global data.
Yeah.
We invest in it.
And I understand that there are privacy concerns, and I get that.
Absolutely.
And, but if you look right now, at least in the media, and you look at what all the criticisms are of AI, right, of machine learning, it's always about the underestimation of variability. That's the problem. So it could be that if people observe me over time, that I have 10 different expressive forms for happiness, and maybe you, Rana, have 15, and maybe they overlap, 8 of them. I don't know. I'm just making up these numbers. But the point is, and maybe some of the expressive forms I have are actually, if you were only measuring the face and the voice and the body, just that ensemble, you might see across 5 different categories. But if you picked up additional dimensions of signal, then you can start to make much more, more precise predictions about what my state, or inferences about what my state is. I think that's really the direction that we need to go. And I think partnering with industry is exactly the way to do this. It will get done much faster. It's not going to be as fast as anybody wants it to be, but it'll be much faster if we partner and do it that way.
So we always like to end our podcast with the same question. In the future, if your car could do one thing to make your life a little easier, what would it be?
It's a really hard question. Because I could answer it,
Do you drive a lot?
I do drive a lot.
Mm-hmm.
I drive a lot.
I do.
Yeah.
So
I could I could give you a funny answer, like, always have chocolate available for me. I could push a button.
Ooh,
and
I'd love
chocolate
that.
would be available, right? Or
that's a new idea. I love it.
Or, always have, I would always I would be able to turn on the radio and turn it on, or turn, stations in a very easy way. It could predict, when my least favorite politician is going to be on NPR and switch the station or something like that. But I honestly think that the things that I most appreciate in cars are the things that keep me safe. Honestly. People always say when you're buying your teenagers or your young adults a car, you should buy them a used car, because, they could get into an accident. But actually, all the best safety features are in brand new cars. And so I bought my daughter a brand new car because that's what I want, right? I want her to be safe. And so I think, I don't know whether there's one expression for drowsiness or 500 expressions for drowsiness, but I don't know.
Or distraction.
But I think that, that anything which keeps me or other people safe is what I would want, or keeps me safe from other people being distracted. I think that's really, anything like that would be something that I would pay a lot more money for, actually.
That's great. Well, thank you. Thank you. It was wonderful having you on our podcast.
Yeah, it's my pleasure.
I hope you enjoyed today's episode. Special thanks to Joseph Friedman, who helped produce the audio for this podcast. Don't forget to subscribe to Affectiva's Human-Centric AI podcast on iTunes, Google Play, Stitcher, or wherever you get your podcasts for new episodes. We are also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram at Affectiva to share any feedback you have on the show, and weigh in on the discussion using hashtag AffectivaAsks. Please also rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.